Hello, sir. Good afternoon.
Good afternoon, Mr. Das. Yes.
Sir, I'm recording this session. Okay. Once the session was done, then I will share you the bunch of videos in Drive directly. Day one, day
Okay.
two, day three, like that. I will be handing you all the details.
Okay, Mr. Das. Huh?
Okay.
So I think yesterday also you have recorded, no?
Yes, I have recorded. I have done that one, sir.
Great.
Okay. Sir, I hope you have, sir, are there any doubts before proceeding that
Yeah,
I would
in
like to
yesterday's
ask?
session there's no any doubts. Okay.
Okay, fine.
So I have tried what you have explained yesterday. Some
Great, sir, then. See,
so
so we will be
one
opening that
thing,
file itself, sir.
what is this open origin and open location, Mr. Baza? In home tab,
Okay.
there's an kind of
No, I will
two.
see. Okay, sir. I will explain you that.
Okay.
So we'll be opening the yesterday's model. For that, we'll be
Correct.
entering into open model file.
Uh-huh.
So this is the file which we have saved yesterday, worked on it, draft one. So
Mm-hmm.
we'll be opening that. And this is what exactly the file which we have worked yesterday.
Mm-hmm.
So this is a 3D representation. In 2D, it was like this.
Correct.
Okay. So you are asking this one. Which one? Home,
No,
open
go to home.
location. This one.
Yes. What is that?
Sir, I will tell you this when we'll come into 3D area. Okay, when we'll come into 3D, I
Okay,
will
that
explain you
will be
this.
applicable in 3D area.
Yes, in
Okay.
3D, we will be having some icons that will relate with 3D
Okay.
only. Okay, so we have done with these things. Let me close all these things. One,
Up to
yes.
stations we have done.
Yes, up to
So
stations we
from
have done. Today we are going to
yes.
cover some sort of conveyors,
Mm-hmm.
different form of conveyors. How the
Mm-hmm.
material will be used on the conveyor. How at all what will be happen if I use a converter. How we need to use a converter table, turntable, turn plate. All the material handling related things we will be learning today, sir.
Okay. So these are all you will gonna teach in the 2D, yeah?
Yeah, in 2D only, sir. No problem. 2D, 3D both are same. Just the conversion. That's it. So after
Okay.
converting it to the same model in 3D, then there will be
Mm-hmm.
having some other representation. That's it. Both will be same.
Okay.
Okay, so now this model is having one source and a drain, and it is having a station, but in real
Correct.
we will be using a connector as a relationship between these two or a process between these two. But in real what will be happen, it is not exactly happen in an industry. Why? Because in industry, the material handling, which means the material from input goes to station by means of some sort of AGVs or some sort of trucks or by sort of some humans or by using some conveyors. Then only the material handling will be performed.
Correct.
But in simulation, what we are going to do is, so we will be planning this one, which means for starting a basic model, we will be using a connector, which means we are defining a relationship between these two to check the initial model. Once the model this is fine, which means this is a model what I, just a second, sir. Okay, let me drag it. Now I'm having three different processes in this plant. So plant process 1, process 2, process 3. Now I have defined a basic model with what I am having. Now I want to replicate actual characteristics to this plant. For that, first thing is I'm having input, I'm having output. Now how the material movement is happening, this is called as a material handling. How the material handling is happening in an industry. If the material handling is happening by the help of a conveyor, then I need to use a conveyor here. For that, we need to remove these sort of connectors here. Now I am having a source, a drain, and a mission. Now I want to connect these things. For connecting these, I need to use a conveyor. For that, so this is what exactly a conveyor is. So if I click this one, so there will be a pop-up here. Again, it is asking me to connect. So what are the things you want to connect? Before starting that, this conveyor will be used for connecting two different objects, whether it may be missions, whether it may be input and a mission, or a mission and an output, or a mission and a mission, that doesn't matter. For connecting this, I mean, for using this conveyor, there will definitely need two things. One is input and one is output. So if I click this conveyor, then it is asking me, there is a pop-up here. So it is asking me to connect two different things. First one, I am connecting, clicking on the source, and second one, I am going to click on this one. A conveyor will be started. Same thing. If there is a conveyor, I want to draw this conveyor on this thing. So first click, second click. If at all I want to extend, I can extend like this. If at all I want to stop it, then right click. Automatically it will be stopped. Here, it won't be possible to delete parts. I mean, I want to delete the only smaller part. It is not possible. If at all I want to delete, I want to delete it completely. That is the only drawback in this thing. Okay, again I am telling you, conveyor, if we want to place a conveyor, then click on the conveyor. It is asking me for two different objects. First object, second object, conveyor was placed. Similarly, conveyor, if at all I want to place the conveyor on an open area, then same thing. First object, second object. If at all I want to stop, then right click, it will be stopped. Else I can directly click, first click, second click, and we can go for escape also. That is also possible. So just a second. These are the two different things. Now I don't want it. Delete and delete. Now I have defined a conveyor here. Whether it was connected or not, I don't know. To check that one, see sir, there is first mission and there is second mission. I want to connect a conveyor between these two. First method is click on the conveyor and click the first mission and click the next mission. A conveyor will be done. Now I want to check whether it was connected or not. For that, so I need to click on this one and drag it, so that if there will be arrows like this, if there will be representation, then it was connected. If there is no line, which means it is not connected, partially connected. If at all I want to connect these two, again mission and this one, it will be connected. Now I can drag it to its position, drag and drop. Just like the mission, I can rename it also. So click on the conveyor, right click, rename. I'll place it as a C1.
What is that label? Why it will be helpful? Label
Label,
after name.
yes,
What is it?
I can describe the operation.
Okay.
Material 1, I can define in detail. So if someone
Oh,
opens it, so there will be C1 is the conveyor name and it is transferring material 1. It is
okay.
transferring some sort of material. Like if there is a conveyor is there. So what is the name
Correct.
of the conveyor and what it is handling, what it is undertaking, that we need to define. We can define here. Right click on the
On display,
conveyor.
we won't see that label.
Yes.
Only
Only the
name will.
conveyor name itself is indicating. In the
Correct. Correct.
label, I can deny
Correct.
material 2. Material 2. So conveyor 1 is for material 1 and conveyor 2 is for material 2. Like this I can. Now I know whether it was connected or not. If there will be an arrow, which means it is connected. Now it was done. Now I can run the simulation. So for running a simulation, again open the event controller, reset the simulation, and I can play. Now see, my parts will be clearly visible because of this conveyor. First part done, second part done, directly entering into this one.
I think from input to machine one, there is an blocking. No.
So this
Correct.
is not a problem. Why? Because input will definitely directly give the directly will give the material.
Mm.
If there is a blockage between station and station, see, this is a simple model. There is only one station. That is why it will be like this. Now
Uh-huh.
I will be using a source and a conveyor here. After that, I will be using a drain and yes. Now this is the model. Source 1,
Mm.
and from source 1 the station 1 like this. Now I
Okay.
want to run this one, reset the simulation and run it. Parts from the source, which means input, from
Correct.
input is continuously giving the material. So the mission 1 is processing it. Once the processing was done, it will be entering into second mission. Second mission is processing, and this part is waiting here. See, in the way it was coming here, second part.
Understood. Understood.
If the time of this mission, maybe I'll increase the time here, it is 10 seconds. If I go it for 30 seconds, I can increase the speed so that it is visible.
Now it's a blocking.
Yes, now
Right.
we will call this as a blocking phase.
Okay.
That's it, sir. Input, it doesn't matter. Why? Because input is continuously giving material. This mission will be the one. After this only we will be considering as a blocking as well as waiting. So before that, from the input section, we won't be considered whether it was a blocker or whether it was waiting. That doesn't matter, sir. Okay, so this is how the conveyor will be. uh, Next thing is, if there is a mission one, and if there is another mission, I want to connect these two, then we can directly connect first one and second one, and there will be a this conveyor, angular conveyor will be there. There is a conveyor like this, but in real, in actual, there won't be any conveyors like this. Why?
Can
Because
we give an angle, particular angle?
yes sir, yes, sir. It is possible, but it is not at all possible in actual industries. Why? Because if I run this one, I will show you. Source.
Just I'm asking possibilities. Huh? If there is a yes, no,
So
then we
got it,
can.
got it. But I have to show that, sir. Why? Because that is why
Yes.
I am showing you that. Just a second. Now, yes. In this model, what happened is there is a source and there is station 3, and it was
Hmm.
connected with an angle, maybe some angle, some 50 degrees or 45 degrees, some different negative 45 degrees angle. But in
Hmm.
real, if I run the simulation, if I slow it down, there will be a gap between mission and this one. That
Correct.
gap, that is not at all possible in industry. Because of that gap, the material may fall.
Hmm.
That is why industries won't use this type of conveyors, this
Correct.
unnecessary angular conveyors. Instead of that one, they will use this type of conveyors. Conveyor only, in that I need to make a straight conveyor. After that, if I want to make any angle, then
Hmm.
I need to press control. I need to press control and hold. So that what is happening here, there is a curvature.
Hmm. Hmm.
First curvature, if I still hold it, then there will be alternate curvature. If still hold it, there will be alternate curvature. If I don't
We
want
need.
it, we need to release. If we release it again, there will be a straight conveyor.
Okay. So whenever we want curvature, we need to press control. No.
Yes, we need to press
Control.
and hold control.
Hold
Then
control.
see, this is like this. Now when I run this model, the part will go through the conveyor. That is why in industry curvatures, I mean the conveyors will be in a curved shapes. There won't be having any sharp edges. There won't be having any straight, I mean angular conveyors. There will be having only curvature conveyors for smoother material handling rates. Clear, sir? Again,
Okay.
for doing that one, same thing. There is a mission, and there will be having another. I want to connect these two missions. Then click on conveyor and press on first mission. From this only I want to start a I mean angle, then hold the control, and based upon your I mean our requirement, whether I want to do it on upward direction or downward direction. If it is upward, then we can move the mouse to upward
Cursor.
direction,
Yes.
cursor. If it is down, then it will be like this. If we still hold it, then automatically the curvature will be continuous. Once it was done, I can do it otherwise like this. One, escape. Then I will be placing this mission here. This is possible. Okay. If at all I want to modify this one, if at all I want to break this one,
Hmm.
in this plant simulation, it is not possible to break a conveyor. Instead
Okay.
of breaking, I can create multiple conveyors like this. First conveyor, second conveyor, done. Again I will be placing some other conveyor, second conveyor. Now
Okay.
there will,
Discontinuity every
yes,
time. Huh?
third conveyor, done. Now if at all I want, I can modify this, I can move this individually. Now if at all I want to move this, everything is moved here, it is a single one.
Correct. Correct.
That is the only
Correct.
problem. But I can change the length. Now this one, if I click this one, there will be having some nodes, some intersection points. We will call it as a nodes, nodes.
Is
So
that intersection point or it's an job?
sir, it's an intersection part only. See here, if I
Okay.
click outside, it won't be visible. If I click this one, there will be intersection point or node,
Okay.
node. So if we
Okay.
click that node, and if we drag, the length will be reduced. Okay, if I click
You
this
can
one,
type. Okay.
angle won't be changing. If the length
Okay.
length will be changing, length will be reducing and increasing. but
Mm.
here it was fixed. This angle is fixed here. If at all you want to modify this angle also, in 3D it is possible,
Mm.
but in 2D it is not possible. In 2D only linear lengths will be going to change. This I can change. And see, this length I can change, this length I can change, even angle I can go for the angle, but angle is not at all correct. So whenever there is a need of angle, in that
We need to
case
use a
we need
curvature.
to use angular curvature, I mean
Angle.
curvature, some radial curvature.
Correct.
So this is what exactly the conveyor concept is. Here, sir, one thing you need to observe. Let me delete all these things. This is a straight conveyor. If you observe the material orientation, part is coming in rectangular way and it will be reaching in the same direction. Now, I am preparing one more model. First, second, and a drain. Yes, it was connected. Now this is case one, sir, and I will be placing same thing, Control C and Control V.
You can do a copy paste.
Yes, sir, we can do the copy paste. But for what will be happen? We need to change everything names. Source 1 1, station 1 conveyor 1 1, station 2 drain 2, like that. Whenever you are doing going for a copy paste, then you need to rename it definitely. Now I will be removing this conveyor. Instead of this conveyor, I will be using this is case 2.
How you have drawn that?
I will show you, sir. Just click on the conveyor,
Mhm.
first part, second. After that, again straight line. I am not pressing any control.
Okay, okay. Uh-huh.
And there will be a straight line. There is a dotted line here. Based upon the
Mm.
dotted line, I can map whether it was a straight or not.
Mhm.
It is somewhat difficult, but still I can manage it. Here, this is case 2, and in case 3, yes, sir. Case 1, case 2, and case 3. In case 1, I am using a radial curvature, radial conveyor. Now I am running the simulation. Just observe this one. So just observe the part orientation on case 1 and case 2. If I remove this also, yes. Now see, sir, this is the condition. In case 1, the material orientation. Here the orientation. if you observe in these two cases, what is happening is in the angular conveyor or in the radial conveyors, what is happening? The part is maintaining this curvature. Based upon this one, the material is also oriented. So if there is a curvature, it was basically converting in that direction, it will be moving. In the angular conveyor, what is happening? See, sir, a part is coming and it is completely changing its orientation from one direction to another direction, and in that
Correct, correct.
direction only the part is entering. But
Mm-hmm.
I don't want this type of thing. See, yes, sir. Now I don't want like this. I want my part to be in this direction only. How the part is
Same
coming in
direction
direction
only.
only, then I need to get a part. But in this angular conveyor, 90 degrees conveyor, that is that is happening. So that is the only reason we are not going to use this type of conveyors, 90 degrees conveyors.
Okay,
Okay.
basically the part orientation will change in
Yes, yes,
this angular
in this
direction.
angular direction.
That's the
Again,
reason we'll be using curvature.
yes. So here, what will be happen if I use a radial curvature is, see, sir, the part is coming and again it will be entering into
Correct.
that area only.
Same. Okay.
Now the case 3. So just observe the case 3. Here I am using the same 90 degrees curvature.
Again, it's changing now.
No, sir, not changing. It is maintaining that. See here, the part is coming and it will be going like this. Whereas here, it was completely rotating. See here, it is rotating. It is not at all rotating. In the
Oh,
rectangular
correct,
shape
correct.
only, it will be coming. So it's visible.
Yes, yes.
Okay, this is called as an angular conveyor. This is called as an angular converter.
Converter.
That is the
Okay.
difference. So whenever there is a need of sharp edge or whenever there is a need of orientation, and I definitely need a sharp edge condition, in that condition, in that case, I need to use these angular converters. Okay, sir.
Mm-hmm.
Generally, this will be used in industry in a smaller length, which will be like this, very small area, at the exact end. So that what will be happened, only one part from that station. Just a second, let
Mm.
me delete this. Done. Now I will be using a conveyor from this to this one. Yes, a part is coming up to this one. Here
Mm-hmm.
only one part, it will be entering here. Again, another drawback for this angular converter is it only takes one part at a time. That is why
Okay.
generally it will be in smaller length. So only one part, and again it will maintain the orientation, it will be dispatching to the next station. Again it will be maintaining, it will be dispatching. That is the main duty for this one. Whereas in conveyor, there won't be any capacity for this one. There won't be any limitations for this one. If 1,000 parts are entering, 1,000 parts will be simultaneously moving like this, like the input. Whereas in converter, it is not at all possible. I will show you that also. If I give a source and an angular converter directly and a drain. Now here the same. From source I am using a conveyor here. Here from source I am using angular converter. Now see the difference. That is the main difference, sir. A conveyor will readily accept the material, whereas converter it will accept only one material at a time, only one part at a time. Once the part entered and it will be exited, then only it will call the second part. That is why this source is only calling one part at a time. Clear, sir?
Understood. Understood.
Yes, that is the main difference between this angular conveyor as well as angular converter. In generally, if at all I want to use anything for material handling, then I will use these conveyors. If at all I want to change the direction, I mean I want to change the direction from one area to another area, then I will be using this type of radial conveyor. This type of radial
Correct.
conveyors. If at all there is a need of angular conveyor, definitely 90 degrees angle is needed and the orientation is needed. And that in that cases, I will definitely go for this angular converters.
Angular, this is an Angular converter, no?
Angular
Okay.
converter. If
Okay.
this will called as angular conveyor. If we use angular conveyor, what will be happen? The orientation will be disturbed.
Correct.
That is the only thing. If at all I don't want to disturb the angular orientation, then I need to use this radial one only. If there is a condition, I need to use a radial, I need to use a angular, at the same time I need to maintain the orientation. At that condition, I need to go for angular converters. Then after this, one more thing, sir. Let me delete. Okay, I'll keep these things here itself aside. There is one more interesting thing. If there is a mission, and from this mission I need to distribute material to three more stations, I can do that by using conveyors, which means a mission can n number of I can connect n number of conveyors with a single mission. At the same time, I can connect n number of conveyors with a single mission simultaneously. See, I'm using a conveyor here. From this condition, this is my first condition, and in second condition I will be directly placing, yes, it was connected, and in third condition, third mission. There are three missions I am connecting with single mission. Now I can run it. No, there is no problem here. There is a source, and from that source I will connecting this to this one. If I run the simulation, then first material will be distributed to this one, second material to this one, and third material to this one. Again, it will follow the same cycle. Once it was done, again second part from the second cycle. Again from the third cycle, first part. This is how
Okay.
exactly it will be, sir.
Systematic way.
Systematic way. We can define that also. We can change that also. That is called as a exit strategy. That exit strategy will be learning in the next session, sir. What will be happened here is, in this one there is an exit. Just like the statistics tab, we will be having different tabs here, out of
Mhm.
which there is a one exit tab. In that exit
Correct.
tab, there will be having these many things.
Okay.
So generally default, any industry will use cyclic only. Why? Because whenever a part is produced, it will define with respect to the order only. First mission,
Right.
second mission, third mission. Again, the part will be entering into 1, 2, 3, 1, 2, 3 like this.
Mhm.
There will be some more. I mean, when the exit strategy will come, I will explain you what exactly this random percentage, all these things.
Okay.
But as of now, this is the material distribution. Same thing,
Okay.
if at all I want to connect two stations, then it is also
Mhm.
possible. If there is a single mission, I want to connect these two with a conveyor, then
Mhm.
same thing, I can directly, I'm showcasing you, sir, this is not right, but
Correct.
I can directly connect like this. From two, what will be happened here is mission, this mission will collect one part from this conveyor, again one part
Mhm.
from this conveyor, one from this, one from this. It will follow a cyclic procedure here also.
Okay.
So this is what exactly strategy, again this is input strategy, this is called as exit strategy. So which means
In
if,
which application we will be using like this? Do you
sir,
have any idea?
in every industry will be using it, sir. Anywhere. Why?
Mm.
Because from a mission there will be having two or three divergent process or convergent process. In that, what will be happen? This mission is a first process of this mission, so it is
Mhm.
producing some common parts, and there is a second mission which is having a huge load. Or let
Correct.
us say, this is from input a part is coming. Let us say milling application. Here a part will be milling. Face milling was done.
Correct.
After that, I
Mhm.
need to go for some drilling application. Again, for every
Mhm.
drilling application, it will take 2 minutes of time, processing time. So each part it is taking 2 minutes of processing time, but I am having a lot of material here. So I want to improvise the rate of production, so that I am using three different missions here. 2 minutes, 2 minutes, 2 minutes for every part. Now I need to distribute the material equally to these three missions, so that my process
Okay.
can increase. At the time, I can use this type of conveyors, and I can give some conditions. So that what will be happen? Material automatically distributed to the respective stations. Like this. This is the one of the example. Clear, sir?
No, clear, clear.
Okay. Now, so this is the main conveyor section. Once we are done with conveyor, sir, I hope conveyor is clear. When
Correct.
you,
There are
yes,
two. One is a straight conveyor, one is an angular conveyor.
yes,
I
when
got it.
you start the practice session, I mean, you will be having clear idea on what is this conveyor and how it is capable of.
Correct.
And again, I'm telling you, if at all you want to modify the conveyor, then click on the conveyor, then automatically there will be nodes will be visible.
No. Correct.
So you need to click that node and you can drag and you can this one. So linear in horizontal direction it will be possible. Why? Because it is in 2D. So only two
Correct.
directions will be possible. If it is a 3D, then we can change this z also. The radius, this everything will also be changed in 3D representation. Whereas as of now in 2D we will be going to change the length as well as breadth of this conveyor. Now conveyor was done and angular converter was done. Now I will be explaining you these three things.
Mhm.
Let me save the model. So I have saved it. Open. Now I'm going to erase everything. So this is the process. Now I want to connect individually, which means I'm using a conveyor from this. Done. I will be copying it and I'm pasting it. I don't want drain as of now. So every machine is connected with its own conveyor. Okay. And we can change the length also, sir. I mean, we can adjust the length by clicking this icon. So once we click this one, by using the arrow keys, we can change this one. We can change its orientation. I mean, we change its length and displacement. Same here. We can click this one and we can move in and move out. Okay, done, sir. Now, a station that is connected with a conveyor. Now, these are the different stations. Let me connect. I'm having common source for all these four stations. Now what is happening? There is a different process. From every process, I need to collect the material and I need to give it to the mainframe or something. So this is generally happen in industry. So what will be in airports? So whenever we will be, I mean, giving our luggage. So what will be happen? They will be they will be checking the weight. Once it was done, they will be placing on this conveyor. So the part will be entered up to this one, and from this one there will be a conveyor like this, and the part will be entered into this conveyor and the material will be moved. So for this type
Correct.
of applications we are going to use uh, so the random procedure is this one. So a conveyor that will end and from this one another conveyor will start, but
Correct.
in actually it is not correct method. This is not the correct method to start this type of process. For this
Okay.
one we need to maintain the orientation. How exactly I need to maintain that part orientation in industry perspective, it is a main thing. That is why if at all I want, then I need to use this angular converter first thing. So I can use angular converter like this, so that the part will be maintaining and it will be coming here. From this I'll be using a conveyor so that the part will be reached. This is first method. I am using angular converter here. And in second method, I will be using turntable. Sir, I will be showing you that. So if you click this turntable and click here, this is the length of the plate it is asking. So this is the turntable. And there is one more icon that is called as a turn plate. This is turntable and turnplate. I'll explain you both in detail, sir. Um, let me give you a simple example: a source and a mission, and there is a straight conveyor. From this, sir, clear? Is it visible?
Correct.
Yes.
Invisible.
Yeah. Now I am using this type of source, which means there is a source and it was connected with a conveyor. And from that conveyor, I am using a setup which will collect the material from conveyor 5 and it will distribute to conveyor 6 and conveyor 7. See, I am doing it. I am entering into this. Now I will be making a relationship between these two, first relationship and second relationship. Once it was done, I will be using two type of outputs, control C, control V, and yes, this was done. And okay, now see, sir, I am resetting the simulation and running it. A part is coming here. This will generally happen in industry, sir, in packing stages. In
Okay.
inspection, in packing, in assembly stations, we are going to use this type of turntables, where what will be happen, parts will be collected from the conveyors, and based upon the part, based if the part is larger in shape or larger in size, it is different from others, then it will be automatically divided to the its own line. So if the part is small, then automatically it will be connected to its own line, like it will be differentiated. We'll call it as a turntable. Okay, so parts will be
This
collected
is a
here.
turntable, right? Turntable.
Turntable parts will be collected and it will be given way to
Correct.
different conveyors. For this,
Understood.
I'll explain you again. So this is the setup. If this is a setup like this, not only two conveyors, if there are some control C and control V, so they will be having these many. Now I want to use it, I can, it is possible. So I directly need to use turntable and I need to draw and drop, which means this is the length, this is the length of the table, how much length you want. So I want this much of length I want, so I can drag and drop here where exactly I want. Once it was done, I need to maintain relationship, input maintain. So this is the input I have given. Now output, how many outputs I am having here? Four outputs. So I need to give four outputs. First, second, sir, here one more thing, the connecting is also matters. I mean, how exactly we are connecting is also matters. First, second, so it will consider it as a 1, it will consider it as a 2,
Okay.
it will consider it as a 3. So if we I mean, if we, what happened? Just a second, it was crashed, sir. Oh, gone. So if there is a input and there is a mission from this, and simple thing, I will be having a conveyor, conveyor 1, conveyor 2, conveyor 3, conveyor 4, conveyor 5, and I will be having drain, 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 connector. Okay, now I want, so this is what exactly my shape is. From this is the input, from this input I am going to give my output to different stations, 5 different stations. So for distributing the material, definitely I need to use turntable. So here outside icon I need to make something that based upon the length. So if the length is fixed, then I can, so for preparing this one, click on this turntable. After that, here you need to select first point, and the second point will be your length. So based upon how much length you want your turntable, so based upon the length you are going to place your second icon. So, once it was done, so it will be like this in 2D. So you need to click and you need to
Want
drag.
to create? Can we change? Can we modify the same?
Yes sir, here
Oh, okay, okay.
it is
That node
possible.
we need to touch now.
Yes, we need to select the node and we can distribute, I mean we can deviate it.
Okay.
Yes. Now I will be giving input from this machine to this one. I will be giving relationship to this one. If I run it, what is happening? It was disturbed. Just a second. The center was disturbed. So let me click this turntable again from this to this one. So this is my turntable and I am giving it. Yes, I am collecting this with this one first, this with second, this with third, it was already there, this with 4, and this with 5. And I can reset the simulation and I can run. Clear sir?
Yeah, okay.
This is what turntable is. Based upon our application, if at all we want to rotate the part, I mean if at all we want to rotate it, or if at all we want to deviate it to some other line from one area to another area, then we are
Okay.
going to use this type of turntable for accessing one part from one area to another area.
Mm-hmm.
There is one more thing that is called as a turn plate. Now I will show you what exactly a turn plate is.
Done.
Same, first object and second object. So this is what exactly the component length and an input, a mission, and a conveyor. Generally, all these turntables, turn plates are connected with a conveyor only. Why? Because the material will be coming at a certain rate. So that to maintain that velocity, to maintain that part from that velocity, so we are going to use this turntable, turn plate, conveyors, or angular converters. All things will be used whenever there is a conveyor only. So directly we can't use this type of convey. I mean converters, angular angle plates, angular turntables, turn plates with directly with a machine. So there should be a certain conveyor for doing that. Now I am running this one. It was done. So reset the simulation. I am running it. I don't know whether, yes, it was connected. So have a look on this one. Part is coming. Sir, it's visible.
Yes, visible, visible.
The orientation of part is changing here. Just
Where
observe in the
inside
circle.
the
Yes,
template.
in
Okay.
inside the circle, the part is coming in this side rectangle and it will be rotating to a clockwise 90 degrees and it will be
Okay.
exiting. Just like the turn, I mean angular converter.
Okay. Just
So
it will turn the part, right?
yes, it will turn the part. Maybe what much of angle, if at all I want to change its angle. See here it is 90
Okay.
degrees angle. If at all I
Uh-huh.
want to change it to 45 degrees.
Okay.
Oh, sorry. This 45 is not possible. We need to give in 90 degrees only. 90, 180, 270 like that. I am giving 180 degrees. So click apply and okay. So it's 180 degrees I have given. Okay. Then I need to give that. It was rotated 180 degrees. Sir, observed.
Okay. Mhm.
Previously it was 90. Now it was 180 degrees.
Correct, correct. Suppose I don't want to rotate in the I need in the same position.
Then no need to use this turntable, sir. Instead, directly we can go for a conveyor.
Conveyor
So
only. No
a
need to
conveyor,
use
yes,
this
no
one,
need to
no?
use this one. Whenever there is an
Correct,
application, so where
correct.
the part need to be rotated for a certain angle, means some
Hmm.
if the part need to rotate, I mean need to work on three directions, X, Y, I mean A side, B side, and C side on all the three sides. Then I need to use this
Okay.
type of turntable so that what will be happen, the part will rotate and it will give it to the next conveyor.
Position. Okay.
Based upon the position, automatically the work will be processed.
Okay.
For that applications, we are going to use this turn plate. This is called as a turn plate, where we are the
Okay.
part will be rotated.
This is the only application we will be using template, right?
Yes, only application, sir. And in
In
turn,
turntable,
yes.
you have given different individual drains to each conveyor,
Hmm.
right?
Yes.
So can we make a single drain? Can we connect all the conveyors with
Yes,
the
sir, we
single
can
drain?
connect, but no problem. Nothing will happen. Okay, in this we can connect, but what will happen in actual it is not possible. Why?
Uh-huh.
Because the material is coming to this one, and how exactly it will be entering into this drain. This is not a,
Okay.
I mean, actual thing. In realistic, in a virtual model, we are creating with a connector. But in actual, so this conveyor need to be, I mean, the length of the conveyor should be like this.
Okay. Okay.
Just a second. Okay, like that, sir. So there is no need of drain also. Maybe it is like an individual process. Here I am using a
Okay.
drain instead of a drain. Maybe this process will be collected again. It will be having some other separate process. Let
Hmm.
us say there will be having some five missions here. This is some other process. Maybe this is the input. From input, after milling, the part will be collected by different stations. It will be distributed to different stations. So each and every station, I mean each and every line, so we'll call this as a line is having different missions. Line 4 is having certain missions, line 5 is having different missions, line 4 is having different missions. Like each and four, I mean every line will be different, I mean the part will be differentiated, the part will be distributed because of this turntable only. Now from this is what exactly the input will be. So for this process we won't be giving any source like this. Here we are directly connecting, see sir, just like this. So we are directly connecting this with this one, and this with this with this, and this with this with this. Fine. I am deleting this one. Control C and Control V, and I am pasting here, and I am deleting this mission, and I am directly connecting this with this one. Same, Control C, Control V. I am pasting here. I am deleting this one. Okay, now I will be having each and individual process from this one. Now if I run this model, it will be like subsequent process. Clear, sir?
Clear, clear. Understood.
Okay. Now we can define this angle also. I don't know what exactly this angle. So I can double click
Okay.
it and I can define the angles. So what is the entry angle, how much angle it was entering? So at 180 degrees the part will be collected. So what will be the
Okay.
exit angles? There will be five different connectors, I mean five different conveyors that will be connected here. Conveyor 2, this is conveyor 2 at an angle 0. This is conveyor, maybe this is conveyor, this is at 260 degree angles. Conveyor 1, this is at 309 degrees. Conveyor 3, this is at 50 degrees. Conveyor 4, it is at 97 degrees. So like if at all
Okay.
I want, I can directly define here by using like this 90. So this angle will be 90 degrees only. So
Now it got edited, huh?
yes, it will. Yes, it was edited, modified. Now what will be
Oh,
happen? This turntable will rotate up to 90 degrees only, and it will
90.
deviate the and it will give the part to the subsequent conveyor. Like that, I can
Okay.
modify this also. Even the entry table also, if it is entry table in straight line, that is by 180 degrees. I can change that also here. Instead of 80 degrees, I will be using 114. Okay.
Mhm.
Apply. No, see, sir. When I click on it, I will be running it. From this, the part will be collected. This is 114 degrees. From this only the part will be collected. Previously 180, from 180 the part is collected, but here I have given 180. So from after reaching this position, the part will be automatically collected.
Okay.
So that is can also be changed because with these things. Now I will be changing it to 180 as a default. Based upon these things, apply. Okay, if I run this one again, this is the same model. From that position only, it will collect the material, it will distribute. So these are the four important things, sir. There
Mhm.
is one thing is a converter, which
Mhm.
is not at all, I mean, that much of useful, but still I will explain you. If there is a process input, let me reset all these things and
Just know one more thing. You have changed this angle, no?
yes,
So where will I get that? Can you show me again? Just show me where will I get that line you
double
have.
click on this one.
Oh, double click on the rotatable.
Yes, double click on the icon which at all. Same with this
Okay.
turntable also. If at all I want to do any modifications for this turntable, double click on this turntable. If at all
Okay.
I want to do modifications on the conveyor, double click on it.
Okay. Okay.
If at all
Got
you
it.
want to
Got it.
do same thing, anything you want to modify, then you need to double click on that icon.
Usually.
So there will be a
Okay.
pop up. Now input and output. There is a mission and there is another mission. This mission is linked with this one. This mission
If
is
this hello,
sir, tell me.
this there is an conveyor. No, if I double click on the conveyor, can I change the orientation of that conveyor? Angular. You can click any one conveyor.
Which one? Angular conveyor. This one.
No, no, no. Next to out of yeah. Next to that. It is.
Where is this angular orientation?
I'm saying now it's a 90 degree. No, there's a conveyor
This conveyor.
attached to this rotary table.
Yes, rotary table. Turntable or turnplate, sir? Which one you are asking? This
This
up
turntables. This one.
turntable application. Okay.
You have attached five conveyors. No,
Yes, five conveyors.
so if I want to change the any individual conveyor to some certain angle,
Okay.
how it will be?
So double click on this one. Entry angle, exit angle.
Exit angle we need to
Yes,
change.
exit
Exit.
angle will be like 5. How many connectors you will be having? Based upon that, the angle will be automatically calculated.
Okay.
So in default, if at all I'm talking about conveyor 1, see there is a conveyor 1 here. The default conveyor 1 is 309. I don't want 309. Maybe instead of it, I want 300 degrees only. So I need to give 300, 300 and apply. So that I will get an estimation. So that I will maintain that with this one. Apply. Okay. If I run the simulation, now what will be happen? The first part will be entering. Second part will be placed. See, this is 300.
Oh, oh, oh.
So I need to place like this. If I don't, if at all I don't know what exactly the 300 will be, then I can balance like this by
So you
using,
have to
yes,
change.
I have to change my use by using cursors in and out directions. By using, I can, now I am making it
Accurately we can't do it.
accurately. We can't do this, but if there is an angle is there, then by using this turn, we need to give that to the turntable itself. Why? Because turntable is having an angle inbuilt in it.
Correct.
So based
Correct.
upon the angle, we will be having something. So this is 300 degrees, so I am making it parallel. I hope it looks like in straight line. So this much of maybe one angle, 1 degree or 2 degree deviation is okay in this digital models. Now it was
Okay,
working
understood.
perfectly.
Okay. So if I want any angle, first I need to change in this rotary
Turntable,
table,
yes, rotary table,
turntable.
turntable itself. So in that you need to go for input as well as output angles. Based upon
Okay.
that you will be getting so clear.
Understood, understood. This is what I wanted, huh?
Hmm.
Understood.
Okay, fine. Next is a this is like what is this one? Converter. So
Converter.
converter is like, see sir, the name itself, the symbol itself indicating, which means parts from this side is entering into this side.
Correct.
Okay, I'll be placing this and this. I'll be dragging it side. Okay, now see sir, this is actually, if it is like this, then you will use this as a conveyor. But what is the necessity of converter is, if I don't want this one, I will be deleting this drain. Now I will be connecting this with this one in the middle. So what will be happen? Just have a look sir. Till this part come, this will work as a conveyor only. When the part is reached, so it will be entering from the middle point. It is like a bridge.
Bridge.
Yes, sir, it is like a bridge. See, from the middle point, see the arrow itself indicating, if I reset the simulation, if I delete this arrow, so
Uh-huh.
there is a C. There is an arrow mark, and in the middle there is a straight line is there.
Correct.
So with this straight line indicates that there is another process. If at all you want, you can add it here. So which means the part
Extra.
will, yeah, the extra part will be entering from this section, which means two different processes simultaneously happening here. This is the common mission. Maybe this 8
Correct.
is a common mission. Maybe here I am doing some surface finish, maybe some buffing operation I am performing here, or chamfer application here. From this application there is a part is coming, and from this application the parts are coming. For both applications I want to go for this, I want to do this chamfer application. Then I will be converting, I will be connecting like this. So what will be happen here? Parts from this station will also come like this, and parts from this station will also
There
come
is no
and will
collision.
join at the
Collision
center.
will not happen, no?
Collision will not happen, sir. Whenever the part will be exited from this conveyor, then only this part will enter.
Okay.
See, if I decrease the length
Mhm.
like this, then you will be having clear idea. Now I will be deleting this one. I will be deleting this one. I will place a conveyor here, lengthy conveyor. Yes, it was connected. Oh, see, sir. If I run the simulation, it will just like act as a conveyor only. The part will be coming and it will be reaching from the center direction. When this part comes, this will be holded. Only one part will go at a time, either from this conveyor or from this conveyor only. Two parts won't be entered into this converter. Clear, sir?
Clear, clear.
See, this is like a bridge. So whenever a part is coming here and whenever their part is coming here, so if this part is coming, I mean, based upon the cycle, one part will be collected from this one part will be collected from this one, like this. So if the second rotation will be from this one, then automatically this part will be holded for a second, and this part will enter into this converter and it will be reaching to this location, to this conveyor. Once it was done,
Mhm.
again this part will be reaching. So there won't be any collision here. There will be having some, I mean, some sensors here. Automatically it will control this conveyor as well as this conveyor both.
Mhm.
So this is generally used for multiple applications. I mean, this machine is having a common application. This machine is having a, like I explained you, there is a chamfer application which can be done for both parts.
Mhm.
Then it is possible.
Okay.
These are the material handling devices in the industry or even in the plant simulation software. First one is a conveyor, where we are going, generally we are going to use for material handling in industry perspective. For
Mhm.
that, we need to start from this one and we need to stop this one
Right.
for a
Understood.
straight one. If at all we want to modify, then we need to click it and there will be some nodes will be highlighted. We need to pick that one and we can drag and drop wherever you want. Generally, this is used for a straight line only, either this straight line or this straight line. If at all you want in an angular, then we need to use this radial curvature. For that we need to click on this one and we need to press and hold control, so that there
Controller.
will be having a clockwise as well as anti-clockwise conveyors, and based upon the length we can go for this conveyor. This is what
Okay.
exactly the conveyors will be. Next one is a angular converter. When the orientation matters, if there will be a need of 90 degrees, at the same time I need to maintain some orientation, then at that point I need to go for this angular
Mhm. We need the
converter.
same orientation. We need to use this one.
Yes, angle
Yes.
converter. If at all I am using a conveyor with 90 degrees angle, then what will be happening here? Orientation is not maintained. Whereas in
Correct.
angular
It will
converter,
be.
orientation will be maintained. Next one is
Okay.
converter. This converter will act as a bridge, which means two parts. I mean parts from different sources will enter into the conveyor simultaneously. That will be the
Mm.
main usage of main application of this converter. Next one is a
Okay.
turntable. Turntable will be used for one single source, maybe not for a one single source. Maybe I'm having two different sources and I need to distribute the material to multiple stations at different
Mhm.
angles. At that time, at that instant, I need to go for this turntable. Whereas in turn plate, I'm going to change the orientation of the part in 90 degrees, 90, 180, 270 or 360 degrees. In the direction I can change the orientation of the part and I can deliver that to the next subsequent stations. These are the five different material handling stations in this plant simulation as well as industry, sir.
Mm.
That's for
Okay.
today's session. I hope it's clear.
It's clear what you explained. This is clear. So then, what about tomorrow's session?
So tomorrow session I am going to explain the material handling cells, that is a robot. Okay.
Uh-huh.
After that I need to collect all these things. There is a bridge. I mean how these things will be converted in 3D. So how the 3D
Mhm.
representation will be. So after converting in a 3D, then how the robot will be visible. And
Okay.
what will be the orientation of all these things in 3D. If at all I want to change something or if at all I want to modify the length or something, then I can use it in the 3D perspective. Then in
Can you
3D,
can you click anything? Can you click on the station? Any station one click, please.
just a second, sir. Yes.
Double click, double click.
Yes.
There is a dialog box. So you will be explaining each and every this one, no?
Yes. This time step will be explained, setup will be explained, failures will be explained, controls, no controls, exit will be explained. These five things will be explaining. Whenever we are working on human, then these will also be explained. Energy will
Okay,
also be explained. So just like this one, conveyor. So when we
okay,
start
okay.
working on this one, automatically all the related things will be covered. Like when we
Because
enter into
today I
3D,
opened,
yes,
so I got
sir.
today I have started working on
Okay, fine, no
software.
problem, sir.
I hope
So,
the dialog box.
yeah. So whenever we will be entering into 3D, so which means the modeling part was completed. So now we will be entering
Okay,
into optimization part. In the optimization part, we will be adding all those things.
okay,
Now we'll be in the modeling. So for modeling section we definitely need a mission, how the material handling will be done, if at all there is a orientation needed, how the orientation will be needed, all those things we have learned so far. Now 2D
okay,
modeling was done. Now in tomorrow's session there will be some more things like this robot as a robot thing. So once I have done the explanation in the 2D, then I will be entering into 3D area. So in 3D representation, how the parts will be monitored, how the parts will be, I mean, converted from 2D to 3D, how the representation will be. If at all I want to change the 3D orientation, how it will be maintained. Once I have done with, it will take hardly 10 to 15 minutes for this 2D to 3D conversion. Once the 3D
okay,
conversion was done, then we will be entering into this mission part. So there will be
okay,
having lot of processing time. If at all, what will be happen if I change the processing time? So if at all I want to involve some failures, so what will be happen with the failures? And the next thing,
okay,
there will be having some charts will be involved. So with respect to chart, how can I supposed to do the optimization? All those things will be discussed in tomorrow's session.
okay, okay.
Okay, sir.
Okay, so thank you so much. Huh?
Okay, sir. Thank you so much.
Thank you so
If
much.
if you having any doubt, just call me, sir. No problem.
Definitely,
That I will
I
try
will
to.
work. I will work on it, and I'll get back to you tomorrow.
Okay,
Huh?
sir. Okay. Thank you so much, sir.
Thank you. Oh, thank you.
Okay, sir.